Hello students. So what we are going to learn is something very interesting in math called differentiation. Okay, so let's first of all understand what is meant by derivative of a function. Now when I say that, let's say that y is a function of x, we can say that define the derivative of the function f, define the derivative of the function f at a given point x in its domain as f dash x, which we also call as dy over dx, which is nothing but limit as h tends to 0 f of x plus h minus f of x over h. So when I talk about the derivative of a function f at a given point x, what I'm looking at is how the function is behaving in this small radius of x. Okay, so how the function behaves. Is the function rising around x, or is the function falling around x, or is it rising and falling or falling and rising? So the derivative of the function f of x is it's going to tell us what's the rate of change in y for a given change in x, for a given tiny change in x. So I can write that the derivative captures the rate of change in y, the rate of change in y for a given change in x, for a given change in x. And this change in x is very tiny. And how do I measure that? That is as h tends to 0. It means around x, if I take x plus h. So if I say that x is moving to x plus h, how is the function behaving? Suppose the function, let's say hypothetically looks like this. Let's say this is my function. Now I want to see how the function is behaving when h is tending to 0. When I say that h is tending to 0, it means I am moving from this point to this point. It means the gap between x and x plus h is shrinking. When the gap between x and x plus h is shrinking, how is the function changing? What's the rate of change in the function? Y equal to f of x. So that is captured by the derivative. That's the logic behind it. How do we apply this to solving problems? Because remember, math is all about also cracking the problems. Okay, so there are two ways to solve for derivative problems. One way is obviously to use the definition using limits, which you can see on your screens. Another way to solve the derivative problem is using the rules of differentiation. Okay, so first of all, let me erase all this off and let me write the limit definition here. So if I write the limit definition just for clarity again, this is limit as h tends to 0, f of x plus h minus f of x over h. However, I'm also writing some of the common rules of differentiation. The process of finding the derivative of a function is called differentiation. So rules of differentiation. The first rule is that if I talk about derivative of a constant, that's 0, because by definition, a constant does not change. Let's say that I have y equals k, where k is a constant. Where k is a constant. Then what will dy by dx be? That will simply be 0. Because k is a constant, it's not changing. There is no rate of change in it. It's a constant, and constants do not change by definition. So that means dy by dx is 0. Okay. Example, if I say that y is equal to 2, dy by dx is 0. The second rule is called the power rule of differentiation. So if I say that y is equal to x to the power n, where n is any integer, or I can even say any real number for that matter. N is any real number. Then in that case, dy over dx is going to be nx n minus 1. Now, obviously, all these rules can also be proved. But in this lesson, I'm not talking too much about the proof, but about the application of differentiation. So if y is x to the power n, the derivative of y with respect to x is nx n minus 1. Let's take an example. Now let's take an example and let's show that the answer comes out to be the same whether I use the limit definition to find the derivative or I use the rule. So for example, let's say that y is equal to x square. Okay, then using the limit definition, what will dy by dx be? Dy by dx will be limit as h tends to 0. So students, this is f of x. What will f of x plus h be? F of x, if f of x is x square, f of x plus h will be x plus h square. Minus f of x is anyways given to us as x square over h. So what have I done? I have just applied the limit definition to solving the derivative for x square, y equal to x square. So f of x plus h is x plus h square. Why? Because f of x is x square. So f of x plus h will be x plus h square. F of x is simply x square. If I solve for this, I can just open up x plus h square using the identity a plus b whole square. I can write it as x square plus h square plus 2hx. Then we also have a minus x square here over h. X square minus x square cancel out. If I erase this particular portion off because we no longer need this, I can write here that this is good. Dy by dx is going to be limit as h tends to 0. In the numerator, I have h square plus 2hx over h. I can take h common in the numerator. That leaves me with h plus 2x over h. This cancels out. I get limit as h tends to 0, h plus 2x. And if I just plug in the value of h as 0 now in the limit, we get 2x. And now if I apply this rule to this particular problem, I should get the same answer. So let's apply the rule. So if I apply the rule here, if y is equal to x square, suppose I make it x square here, then using this rule, it's going to be nx n minus 1. Now n is 2, so 2x 2 minus 1, which is 2x. See, I am getting the same answer. Using the limit definition also, it's 2x. Using the rule of differentiation also, it's 2x. So if a question is based on using limits to find the derivatives, we use the formula limit as h tends to 0 f of x plus h minus f of x over h. Otherwise, if nothing is mentioned, we can use some of the good rules of differentiation to solve for simple differentiation problems. Okay, so I hope all students have enjoyed this short lecture on introduction to differentiation. This is where I stop in this particular lecture.